Well, it's finally here. It's been a long time in coming. It's our day for our contact with the International Space Station. We had so many great questions. It's awesome to see all of you students participating, and you're the best questions of the best, so I'm so glad you're here. So we're fortunate to have many people with us today who are going to share with us their experience in many different ways with STEM careers. We know that STEM is science, technology, engineering, and math, and there's so much of that rolled into this day between the astronauts that we're going to speak with and also getting this whole production off the ground with all of the radio volunteers. So we're going to see a lot about how that works today. The first person I'd like to introduce to you is Stephen Murrell. He is an astronomy professor at Henry Ford College, and he is going to tell us a little bit more about some of his experiences with STEM and space. So, thank you very much.
Thank you. So yeah, I'm a product of the STEM education system. I've been working in industry and in academia now for, I guess it's going on 30 years or something. My most recent career path has led me to teaching at Henry Ford College. I used to be a physicist and engineering person, so I did that for a number of years, and now they pay me to talk about the kind of stuff I'm getting ready to talk to you about. Mary had asked me if I wouldn't mind speaking to you folks today, and it took me a while to figure out what I wanted to talk about. But Mars has been in the news lately, and I figured I would sort of stick with the space-related activity today and talk to you about Mars. So I'm going to mention a few things about what we're doing on Mars, what we've done in the past on Mars, and what we're planning to do in the future on Mars. So I guess with that, I'll get started. Okay, so Mars exploration has involved actually several different countries around the world. I'm going to stick for the most part to the U.S. involvement, kind of what we've done. I'm going to do a quick introduction to what we've done in the past and then what we're doing presently. Okay, so starting with the very first mission. By the way, there have been 43 attempts at various Mars missions. This is the very first one in 1960. This is a Soviet Union attempt, and it failed to reach Earth orbit. Here's the second attempt. Failed to reach Earth orbit. What that usually means is an explosion, okay, either on the launch pad or on the way up. Okay, finally in 1962, the same program, again a Soviet Union program, was able to finally reach Earth orbit, sort of. Okay, it got up to a high altitude, almost inserted into orbit, and it exploded. The next one, 1962, finally made it into orbit. In fact, it finally made it en route to Mars, and it lost communications. So, as you might imagine, this is a very highly technical thing to try to do. So, just like any other of our activities, we seem to kind of have to do a few failures before we make successes. Okay, fully half of the missions that we've tried to send to Mars have failed. But I'm kind of a half full glass person, so another way to say it is half of our attempts have succeeded. So I'm going to talk to you about a few of the successful missions, including the Mariner, Viking, Global Surveyor, and Pathfinder. 2 of these are orbiters around Mars, and 2 of these are landers. The first one's Mariner 9. This holds a distinction of being the very first orbital object around another planet. Okay, so this was in 1971. This is a U.S. program, and it is actually famous for making a few, not necessarily discoveries, but the first high-resolution images of some of the more important features on the surface of Mars. This is Olympus Mons. This is the largest volcano in the entire solar system. Okay, it's now extinct because Mars is geologically inactive now. This is the largest volcano in the solar system. How big is it? It's the size of Arizona, okay, and it's 3 times the height of Mount Everest. So it's an enormous volcano, but as I said, it's no longer active. It also took the first high-resolution images of so-called Valles Marineris, which, by the way, was named after the spacecraft itself. This is a canyon feature, kind of like the Grand Canyon in the United States, but much, much larger. It would stretch from Chicago to Los Angeles, and it'd be about 4 miles deep. So it's a very, very large canyon feature. Another geological feature that, again, is on the surface of a dead planet, dead for the most part. Okay, 1976, we sent up a couple of landers. These are called the Viking landers. There were 2 of them, and I'm going to show a quick video of these. Go ahead, next slide. They were launched in August and September of 1972, left Earth orbit, and about 10 months later, finally reached Mars orbit. And it's a combination. What you're looking at here is a combination. It's the orbiter and carrying on its back. You'll see it right here being dropped. That's the lander. And it landed using its own rocket engines to sort of gently bring it down to the surface. And it's equipped with a whole bunch of sensors, including basically some chemistry sets where they were able to analyze some of the soils and things like that. They are doing, in fact, the whole history of Martian exploration, the primary objective has been to sort of study the surface and find out if there's any evidence at all of life. Probably in the past, when I say life, I don't mean little green men with antennas. They would be happy enough to find microbes or evidence that microbes have even existed in the past. And to date, there has been no conclusive evidence of life on Mars. But in a couple of minutes, I'll mention some exciting stuff that's going on right now. This is the very first image ever taken on the surface of Mars. This was an image taken from the Viking lander, basically looking at one of its feet and a couple of rocks nearby. Not very exciting to look at now, but if you're the very first one to see the surface of Mars close up, that was really exciting for the scientists working on this. This is the first color image taken from the surface of Mars, and I remember watching this on TV when I was a little kid. This kind of had a big impact on me. You're looking at real color image of the surface of Mars. Again, it never had been seen before. Between the Viking landers and the global Surveyor, you're looking at almost 20 years where there was several more failures and restarts of various programs. But finally, in 1996, we sent the global Surveyor orbiter up. And this satellite is famous for basically sending over 7,000 very high resolution images of the surface of Mars, and it's still in orbit around Mars right now. It's inactive. This is some of the data that it received. This is a false color image of the surface of Mars. This is the entire globe. And you can see Mars is collecting craters now, and I tell my students whenever you see craters on the surface of a planet, that means the interior has cooled. It's geologically dead. But long ago, since it had so much geological activity, there's Valles Marineris that I had pointed to you earlier. There's Olympus Mons, okay, several other volcanoes. So it used to be very geologically active. And what's happened since it was geologically active, Mars is much smaller than Earth. It's about half the size of the Earth. And the planets are still cooling from when they formed. So Mars cooled much quicker than the Earth. So for a while it had a molten interior. It had a nice magnetosphere. It protected its atmosphere from the solar wind, etc. But that's all since died out. Mars froze out. There's no more magnetosphere. The atmosphere is being eroded slowly by the solar wind. So it's we call Mars kind of a geologically dead planet, again, as evidenced by the collection of craters that you see now. This is one of the, I don't know how well you can see it back there, but this is one of the exciting pieces of data that you've probably heard about recently. For a very long time, we knew that water used to be prevalent on Mars. It used to rain, it used to be rivers, lakes, and streams of water. So we see evidence of that, but we had yet to see any evidence that water existed today on Mars. It's very, very unlikely because of the very low atmospheric pressure. But what you're looking at here are two images taken by the Global Surveyor of part of a crater. This is 2001. This is 2005. You see this difference here? That is an actively flowing gully of water. Okay? That was very exciting, and they've since found several others, and they've been confirmed to be flowing water. So they only, even though this was taken in, this discovery was made in 2005, it took almost 10 years to confirm it and find other evidence of that existing. So the issue, though, is this would have evaporated almost immediately. Yeah, question. It's salt water, as it turns out. Yeah. Of course, they didn't know that when they took these images, but the more recent data that they've been collecting, it appears to be very salty. Okay, this is the first rover that was landed on the surface of Mars. This is the so-called Sojourner. In fact, this was named by a similar competition that you guys had. This was named by some, they had a bunch of students submit names, and this one was finally selected as the Sojourner. This is a little robot. It's got a solar panel on top of it. That's how it derives its power. Drives around very, very slowly. As a matter of fact, it's piloted remotely by people or engineers back here on Earth. The only issue is there's several minutes of delay time. So they would send a command for this thing to roll a few inches. They'd take a picture of where it ended up. Then they'd send another command to let it roll a few inches. So it explored just a very, very small part of Mars. It only moved, in 83 days, it only moved the length of a soccer field, okay? But it holds distinction as proving a few things. First of all, a very low weight, low cost orbiter. This was the very first one, and it kind of set the tone for a few others that I'm going to be talking about in just a quick second. I think it just advances it automatically. Okay, so let's talk about what's going on up there right now. The first one I'm going to introduce is the Mars Odyssey. This was launched in 2001, and next slide. It's famous for being the longest active mission around Mars. It's been ongoing for 14 years, and its main purpose in life is to relay communications between us Earthlings and these rovers that are rolling around on the ground, which I'm getting ready to talk about. Mars Exploration Rovers, this is Spirit and Opportunity. Two different rovers, okay, that were sent there roughly at the same time in 2003, and they're still active. One of them is still rolling around, okay. Opportunity is still rolling around. Spirit got stuck in some soft soil or soft sand, and they were unable to get it loose. So they're using it now as kind of a base station. It's still doing some research, but the other one, Opportunity, is actually still rolling around. These are kind of interesting. This is how we landed both the Sojourner that I just mentioned a minute ago and the Exploration rovers. Here you see it sort of air braking with a heat shield entering Mars's atmosphere at a very high speed. So what little air or what little atmosphere there is enough to slow it down somewhat. Deploying a parachute. And then things get really interesting. Okay, so the parachute's going to continue to slow it down. The heat shield drops away. Bringing it lower and lower down. In a second, you're going to see some rocket engines firing that basically stop its descent. And there you go. Airbags. Okay? This was the second time this was attempted. The first time it was successfully done with the Sojourner probe. All right, so inside of that are these rovers. There's one inside of this one, and they did the same thing for the second rover. It will eventually stop. Gravity on Mars is about a third of what it is here on Earth. So then these will deflate. And could you imagine being a Martian walking up and seeing something like this? It reminds me kind of like the Aliens trilogy. So there's that's one of the rovers all folded up. You'll see its power source getting ready to open up. These would be solar panels. And then the wheels will deploy, and you'll see a mast sticking up, and on the end of that mast is a stereo camera. These are also equipped with little drills where they could drill into rock and take soil samples, etc. Yeah, there's the mast with the cameras. Has anybody seen the movie Martians? Yeah, he finds one of these. Very good movie, by the way. It's entertaining. So again, these things weren't designed to survive nearly as long as they have. They've restarted or extended their missions several different times because they've been so successful. They were also responsible for confirming evidence that water existed in large quantities on the surface of Mars. Okay. This is an image you probably are having difficulty reading from where you are. Let me point out a couple of things. These are the distances of various either autonomous probes or the astronauts driving the lunar vehicle on the surface of the moon. So you're talking about several miles for these Opportunity rovers, right? 25, 30 miles, okay, and still going. So the first one went about a soccer field. Now these second ones are going several dozen miles. And so that's actually fairly interesting. Here's how far the Sojourner got, right? And here's the Opportunity. So these Opportunity autonomous vehicles have traveled much further even than the astronauts when they were driving around on the moon. This is the most recent. This is the Mars Science Laboratory. It's nicknamed Curiosity. By the way, if you wanted to research any of these or learn more about them, go to space.com. It's a great resource for learning about the different probes and things that are going on up there right now. We landed this one on Mars in 2012, just a few years ago. This is about the size of a minivan or an SUV. So they're getting a little bit bigger every time. We're able to get more and more sensors on these things. I want to show you, though, how this one was landed on the surface of Mars. This one kind of blows my mind. Same kind of thing. You have heat shields slowing it down. You'll see that in just a second. So this part will look familiar. It'll deploy a parachute also to slow it down even further. And they purposely land these things near ancient riverbeds and ancient lakes. Yeah, quick question? I'm sorry? Yeah, okay, so the question was, since it's as big as a minivan, why can't we cram a couple of people in there? The issue is living for 10 months or 10 months on a spacecraft, getting to space. So manned exploration is very expensive and much more risky. Sending a probe, autonomous probe, is usually much less expensive. And if they crash, at least you didn't lose human life in so doing. I will talk about manned exploration in a second, though. So again, this is really interesting. This is a rocket-powered, completely autonomously driven. We could not communicate the commands from Earth. It's too far away. So the computer on board had to make sure it understood exactly where it was, how it was oriented. These rocket engines were guiding this thing to a suitable landing site. And this is called a sky crane. So you'll see in just a second, it will drop the rover down on a cable. Again, completely autonomously done, just through computer programs. So gently lowers it to the surface. And then the cable was cut and the rocket flies away. At least 100 yards away. They wanted to get as far away as possible because obviously they didn't want to have it land directly on top of the rover that they just dropped there. So you'll see it looks somewhat familiar to the other rovers, but again, it's much larger and it's powered slightly differently through yeah, it's not solar driven, it's powered through a plutonium reactor essentially. Okay, so just real quickly, future Martian exploration. Go ahead. A new Mars Science Laboratory is being planned for as soon as 2020, sending the next one, the next generation rover to the surface of Mars. It's going to continue the search for any kind of evidence of life, as well as perform some experiments to prepare for human exploration. And in 2035, right, which puts you guys right at about the right age, they're expecting, or at least hoping, to have the first humans reach Mars. They're already, the spacecraft that they're intending to use is in its design phase right now, designing and testing. In 2023, it's going to be, we're going to start putting humans on this and running tests. It's similar to the old Apollo program, which you're probably not familiar with. It's what got us to the moon and back. This is much larger and more powerful. So in 2035, if everything goes according to plan, we might have people visiting Mars. So keep your fingers crossed for that. All right, that's all I had for you. So thank you for having me. Are there any quick questions? Do we have time? Are we out of? We're okay? Okay. Well, thank you. I guess I can't take questions. Thank you.
All right, hello, my name is Gordon Scannell. I'm call sign Kilo Delta 8 Charlie Oscar Juliet. That's my assigned by the FCC call sign that I use whenever I talk on the radio. I'm here to basically help introduce our astronaut that we'll talk to in a couple minutes. We have a little biography video that we're going to cue up here, and we'll meet. His name is Kjell Lindgren. This gentleman that you're going to be introduced here, and then we'll talk to him in space in a couple minutes here. So welcome, and let's meet Kjell.
So for as long as I can remember, I've wanted to be an astronaut. I had this goal of becoming an astronaut, this dream of becoming an astronaut. And I understood that the Air Force Academy was a good way to do that. And so I decided that that's where I wanted to go. That was my top choice, and had the great fortune of being accepted there. I think many of the things that appeal to me about skydiving have a direct application to working in the space environment. It can be a very dangerous activity if you don't take all of the appropriate precautions. We're very careful about our equipment. We use checklists to make sure that all of the appropriate things have been done in preparation for a jump. You crawl out, you can feel the wind blowing over you, and then you all leave the aircraft at the same time and get into a formation. The feeling of opening shock is a little jarring, but it's a comforting one. You know that your parachute is opened and that you're on your way safely to the Earth. Flying under the canopy is an incredible experience. Feeling the wind rush past you and controlling your descent to where you want to land. I had the opportunity to jump into our Air Force football games, so jumping into a stadium with tens of thousands of people watching is quite an experience as well. The habits that I built while I was working on the parachute team are things that I think transfer to working in the aviation environment, flying in a plane or operating in space. I'm Kjell Lindgren, and I'm an astronaut.
Thank you. I'd like to introduce Larry Koziel. He's an amateur radio volunteer. He's helped us extensively with our contact here today with the International Space Station, and he does this often. Actually, he works with a group. He's a volunteer with a group called ARIS, and it's amateur radio aboard the International Space Station. That's what that stands for. So Larry's going to tell us a little bit about that experience. Thank you.
Okay, thank you, Mary. Well, who here is excited about talking to an astronaut today? Let's see some hands. That's great. I know because I've been involved in amateur radio for quite a long time. I got interested about the time I was in 8th grade, although it took me some time to get a license. And a license is required. You need a license from the Federal Communications Commission. And it took me until I was 20 years old before I got a license. But this is the second time I will be talking to an astronaut to get things kicked off here in space. I've met a couple of astronauts in person through ham radio, through amateur radio. And I'll tell you, the first time I did this, it was the most thrilling thing I've done in amateur radio. And this one is going to be the same. So let me explain a little bit about what amateur radio is. It's been around since the beginning of radio. When radio was first invented, there weren't companies developing radios and so on. People in their homes, in their basements, their spare rooms, were experimenting around with radio and talking to each other, having conversations via radio. And it's the same thing today. People all over the world, as a hobby, experiment with radio. They build radios, they design radios, they talk to each other. You can talk with some of the equipment we have on the table here. You can talk as far away in the earth as possible, to Australia, to Europe, to Africa, and most of us here have done that many times. Let me explain a little bit about what we have on the table here. We have two radios. We have the radio that we will be using as our first choice, and NASA is very careful about things. They like backups, so they've asked us to have a second radio in case something goes wrong with the first one. They want a backup. From this radio, the signal will go through these cables. You see it. You may have seen on the floor when you came in, up to the roof of the building, where we installed an antenna that's about 19 feet long, and that we can steer in the direction and the elevation. We have a picture here. This is one night when we finished getting the antenna up at sunset. The long antenna there is about 19 feet long. That's being steered by a computer program running on this computer that it calculates where in space the space station is. It knows where on the Earth that we are, and it calculates which angles to steer the antenna to send the signal towards the space station. If you want to go to that globe view, click the, yeah, there you go. He's going to move it over once he gets it. This is another view of what the orbit looks like. And the space station in just about about 11 or 12 minutes from now, the space station will be coming from this direction, and it's traveling at about 17,500 miles an hour. And right here in Dearborn, it's going to come by, and it's going to pass by just eventually to the north of us and go off across Canada and the Atlantic Ocean towards Europe. And if we can look at the other view yet. Let's go to the radar view, yeah. So this is the view looking down at our location. This is the school right here in the middle of this plot, and this shows different directions, north up here, east, south, west, and these circles are the angle of above the horizon. And it's a little hard to see, but there's a green line here that runs here. The space station will come up above the horizon like the sun does in the morning in the east, and it'll rise to about 57 degrees at this point here and then begin to set. It'll go down lower towards the horizon again. Now the directions of course are different from the way the sun rises and sets, but it's the same sort of principle. So altogether, we'll have about 10 minutes from the time the space station comes above the horizon in the southwest until it sets in the northeast. So in order for everybody to get all their questions in, we have to be very efficient here. You'll have to step up when it's your turn, ask your question. When the answer begins, we ask you to step aside so the next person behind you can get ready to ask the question. Now, go ahead. The question is, does the space station move faster than Earth? And the funny thing is, the space station is in a low orbit in Earth. It's only about 250 miles above the Earth. And the Earth makes one rotation in a day, and the space station makes something like about 16 orbits in a day. And the funny thing is that the closer a satellite is to the Earth, the lower the orbit, the faster it goes. If a satellite is in a much higher orbit, it travels much more slowly. So exactly more or less than the Earth, I'm not sure, but being so low, it does travel very, 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 very fast. Okay, so the signal goes up to the roof to that antenna. If you go back to that radar view again, as I said, we'll have the computer automatically pointing at the space station. You'll see there's a little circle here, and that represents where the antenna's signal is aimed. And you'll see that follow the representation of the space station as it moves across the sky. Up here, there's a bunch of numbers. They're probably not readable, but those they tell us what time the space station will come above our horizon, what time we expect it to go below the horizon again on the other side of the sky. It tells us the angles and so on. And there's a countdown timer on there that tells us how many minutes and how many seconds before we should expect to hear the signal. Now, these are predictions based on knowing where the space station was at some instant in the past. And the software in the computer figures out where it is now. And sometimes, due to conditions in the atmosphere and so on, it may be possible to hear the signal a little bit earlier than the computer predicts. So we'll begin calling the space station a little bit before what's called the AOS time, the acquisition of signal time that the computer program is predicting. And the signal might be a little bit noisy at first, and because the signal will be coming so close to the ground, as the space station gets higher in the sky, the antenna will be pointing away from the ground and the trees and buildings and so on, and the signal should get better. And conversely, as we're nearing the end of the pass and the elevation is very low, the antenna again will start pointing at things on the ground, and the signal may become somewhat noisy again. So just be aware of that. I have to re-emphasize that these are not telephones. This is not the internet. We are sending a signal directly out into space to the space station, and we're hearing a signal that they're sending back. And so the conditions of the atmosphere and so on affect the quality of the signal and the strength of the signal. I would, well, we have a couple of minutes left here. I would remind people to give us the courtesy of turning off cell phones, or at least making sure that they don't ring. We have to coordinate with NASA. NASA has a couple of telephone numbers of phones that will ring in this room. And if we hear a phone ring, we're going to assume it's NASA. And if it's somebody else's phone, we're going to be a little bit upset about that. So please cooperate with us in that sense. And again, about the station, I said NASA is kind of very careful. They also required us to have yet another sort of backup in the event that we lose power in the building. We have virtually all of this equipment running off of batteries, so we'll be able to continue even if we lose power here. Yes? Okay, he said every time he plays a game, he has backups for his backups. And that's very, very good policy to have. Let's go to that, the APRS. At 10:30 this morning, we were able to listen to the space station go by at that time on the orbit just before this one. And on board, in addition to the voice communications that the astronauts do, there's also a radio that can send digital information, and that's what we had here. This actually was captured on my iPhone. I put my phone down on top of the radio so the phone could hear the sounds coming out of the radio, and this is what was decoded. Now, what this is known in amateur radio as packet radio. We are amateur radio operators on the ground are sending packets of data, small groups of data that go up to the space station, and the space station sends them back down. So there are people here. Here's somebody from Alden, Pennsylvania saying hello. This 599 is a signal report. Some of these abbreviations you might know from texting, like UR. You know, I'm sure you know what that means. This RS0ISS, that is one of the call signs. That's a call sign. That's a Russian call sign. There's a radio, an amateur radio in the Russian portion of the International Space Station, and it has its own call sign issued by the Russian government. The call sign that we'll be using today on voice is an American call sign. We'll be calling up to NA1SS. That is the space station call sign for the American segment, and we'll be using the call sign of the Ford Amateur Radio League right here in Dearborn. Their call sign is K8UTT. So you listen for those when we make the call to the station in just a couple of minutes here. But people, people are doing this from their homes, with a small radio like this and a computer amateur radios all over the world are using the International Space Station whenever it passes by to send messages amongst themselves. And there's I'm sorry, there's so much more to say about amateur radio and its connection to space, going back to the first artificial satellite back in 1957 when the Soviet Union launched it, and they chose frequencies that amateur radio operators all over the world could listen to, and that's how the rest of the world knew that they really did launch the first satellite. And just 4 years later, amateur radio operators built their own satellite, and we've been doing so ever since. And there have been well over 100 amateur radio satellites launched since that first one in 1961. Okay, we got the word here. We are just about at AOS, and we're going to give a call.
NA1ISS, NA1ISS, this is KUTT, Kilo 8, Uniform Tango Tango, calling on schedule. NA1SS, 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 this is KUTT, Kilo 8, Uniform Tango Tango, calling on schedule. NA1SS, 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 this is KUTT, Kilo 8, Uniform Tango Tango, calling on schedule. NA1SS from Kilo 8, Uniform Tango Tango, we hear your signal, but very weak right now at this low elevation. Over.
You're also weak, but the signal is becoming stronger. I can read you.
Okay, fine. Your signal is beginning to come up, and I suspect another couple of degrees elevation will be very strong signals from you. If you are prepared to take questions, we're ready to go now. Over.
Okay, and I'm really excited to be talking with the Dearborn Public Schools and with the students in Detroit, and I'm ready for the first question.
Hi, my name is Brush your teeth. Over.
Thanks for that question. Brushing your teeth in space is one of the things that really doesn't change too much. We don't have running water up here, so we have to squirt water on our toothbrush with a little drink pouch. But other than that, we brush our teeth normally. But because we don't have a sink, we just have to spit the toothpaste into a tissue. Over.
Hi, my name is Stavros, and my question is, what do you do if you ever get ill or hurt? Over.
Great question, Stavros. We have medical supplies up here, medicines, as well as medical equipment. And all of the astronauts, all of the crew have been trained a little bit on how to use that medication and equipment. We have a flight surgeon, a doctor that's just in mission control that can help us if we need any help. In my background, I'm actually an emergency medicine doctor, so if any of my crewmates get sick, I'll be able to help. Over.
Hi, my name is Haneen. What is the official language on board the International Space Station? Over.
Hi, Haneen. It's a great question because it is an international space station. We have many, many partner countries, and right now we have 3 Russians, 2 Americans, and 1 Japanese astronaut. So we all speak English on the U.S. segment of the space station, and we try to, and of course our Russian colleagues speak Russian to each other, and when we're together, we mix up Russian and English a little bit. Over.
Hi, my name is Ryan. How would you describe the feeling of being in space? Over.
Lynn, thank you for the question. I would describe the feeling as exhilaration. It's so wonderful to be up here, to be able to float around. It's something that I've dreamed of doing for as long as I can remember, and so I'm very excited and honored that this dream has come true. Over.
Hi, my name is Sarah, and I'm filling in for Yasmin. What do you guys eat in space? Over.
Thanks, Sarah. we have a pretty diverse menu. We have a food laboratory that helps make the food for us. We can't cook up here with ready ingredients, so instead we have foods that need to be heated up in pouches, or we have dehydrated food, and it's pretty good. So my favorite meal right now is beef steak and barbecue brisket. Over.
Hi, my name is Mohammed. Do you see the Earth, Sun, and Moon rotate? Over.
Mohammed, great question. You know, we see the sun pass over the top of us, just like you do, and we see the moon pass over the top of us as well. The thing that we notice the most, though, is the Earth below us, because we're going 17,500 miles per hour, and so we see the Earth pass below us very quickly. We end up seeing 16 sunrises and sunsets over the course of 24 hours, and it's beautiful. Over.
Hi, my name is Abdul Rita. What was it like when the supermoon lunar eclipse came into your view? Over.
Abdul Rita, thank you for that question. I wish I had a great answer for you, but unfortunately, the lunar eclipse happened at 2 o'clock in the morning on a Monday morning, and so I made the decision to just go ahead and sleep so that I would be ready for work on Monday. So I imagine, though, that many of you got a wonderful look at that neat space phenomenon. Over.
Hi, my name is Ali. What is your most recent successful experiment you have done on the International Space Station? Over.
Well, Holly, thank you for the question. You know, we have many experiments that are going on, and so there's no experiment that's really completed while we're up here. I'll tell you that my favorite experiment so far was working on the veggie experiment, and that's where we actually grew lettuce here on the space station, and then we were able to eat it at the end. So I made it into a cheeseburger. Over.
Hi, my name is Samantha. How do you sleep when there's no gravity holding you to a bed? Over.
Great question, Samantha. Some people have a hard time sleeping without gravity. Some people we all sleep in sleeping bags, and some like to strap their sleeping bag to the wall to give them the sense of pressure on their back, like they're sleeping at home. I like to sleep floating, so I just have one tether strapping my sleeping bag to the wall, and then I get into it, and I just float in that in my crew quarters, and I sleep very well. Thank you. Over.
Hi, my name is Brooklyn. How do you stay fit in space? Over.
Brooklyn, we have 3 different exercise machines, a bicycle exercise cycle, a treadmill, and then we have a resistance machine so that we can lift kind of like you were lifting weights. And all 3 of those help us to stay healthy, help to keep our bones strong, muscles strong, and heart in healthy condition. Over.
Hi, my name is Dana. When you're about to take off, how do you feel? Over.
Yeah, I was very excited, and it's kind of like I feel today, actually. We have a spacewalk scheduled for tomorrow. So Scott Kelly and I will be going outside of the space station, and so there's this feeling of anticipation and excitement, and really looking forward to the challenge. Over.
Hi, my name is Ella. Do you have any side effects when you return to Earth? Over.
Ella, great question. You get used to living in 0G, so when you get back to Earth, gravity feels kind of like a bummer. It's kind of hard to move around. You get kind of dizzy because you're not used to gravity pulling down on your inner ear, on the organs that help you maintain balance. But after a few weeks, you feel back to normal. Over.
Hi, my name is Nada. How do the astronauts cope with the physical state of being away from their families and friends for a long time? Over.
Thanks, Nada. That's a great question, and it's probably the biggest challenge for me is being away from my wife and children. But we have lots of tools up here with a phone that we can call back down to the Earth. We get video conferences every week. And so that does a great job of keeping us close, even though my family is far away. Over.
Hi, my name is Samira. How does our digestive system work in space with no gravity? How does the food go down our throat and stomach?
Great question, Samira. That's something that space doctors were actually very concerned about before we sent the first humans into space. And it turns out that the digestive system can work without gravity. You have smooth muscle tissue in your digestive system, and it kind of works to squeeze this food along and keeps it moving, just as if you were on the Earth. Over.
Hi, my name is Khadija. How long can an astronaut stay in space before having to come back to Earth? Over.
Look at you, Joe. We don't know the answer to that yet. That's part of what we're trying to determine here on the space station. And Scott Kelly, one of my crewmates, is going to be up here for a year. And this is all in preparation for the possibility and the goal of going to Mars by in the next 10 to 20 years. And astronauts that do that will be gone for maybe 2 to 3 years. So we are trying to figure out ways to keep people healthy for that long duration.
Hello, my name is Abraham. Is there a way that the space rocket ships could reduce the amount of energy they use? Over.
Well, Ibrahim, a certain amount of energy is required to get up the incredible velocity of 17,500 miles per hour to get into orbit. We are looking for other ways to provide that energy. Right now, but figure out new ways to space travel.
Okay, I don't know if you can still hear us, Chell, but we certainly appreciate the time and the thought you put into your answers, the time you've given us. And I think everybody here wants to show their appreciation with a big round of applause. NA1SS, this is KUTT signing clear. Thank you very much, Chell, and as we say in amateur radio, 7-3.
All right. Thank you very much. Thank you especially to the students who came up with those great questions. Chell had a really good time answering. You can tell he had very good answers to them. He was had such good answers that we ran out of space overhead before we ran out of questions. So if anybody is interested in the type of stuff that we do as amateur radio operators, we do have a selection of flyers and brochures. The youngest amateur radio operators are 5 years old currently, so none of you guys are too young for that. And regardless, it's a great way to understand and apply all that science, technology, engineering, and math that we have. So, we have a question? What happened was that the space station was only overhead for 10 minutes, and so. As you could tell, we couldn't really hear the astronaut, Dr. Chell, anymore, and so we couldn't hear his answers. We weren't sure whether he could hear us anymore, but unfortunately, we couldn't hear him any longer. Remember that space station's flying overhead, just like the sun does, only a lot faster. And when it goes below the horizon and becomes sunset, we can't hear them anymore.
Yeah, and I have to say that we were transmitting with 100 watts of power. And our antenna, the antenna we have on the roof actually made the signal sound even stronger than a 100-watt signal. And the signal that they're transmitting from the space station is much, much less. It's about 5 watts. They obviously have a much simpler antenna on board than we do. They don't have something that could point directly at us. And it's certainly not 19 feet long like ours is. So chances are he could possibly hear us, but we would not have heard the answer. And of course, if he had given shorter answers to the to the questions, we might have gotten more questions in. But I sincerely apologize to the 3 students that we had that did not get a chance. I'm sorry about that, but as you learn in STEM, that's how the physics of it worked.
In closing, I'd just like to say thank you again to all of the students for participating with their great questions that we had for our astronaut today. And thank you to all the parents and administrators and teachers that helped to get students over here, mostly parents, I guess. And thank you, very, very special thank you to Gordon Scannell, who basically brought the opportunity here to us at Dearborn Public Schools. Without Gordon sharing this whole program with me, I would have known nothing about it. Thank you to all of the volunteers for the countless hours of work that you've put in here since the summer to get this, this contact off the ground. So again, thank you so much to everyone. Thank you for being here, and until our next contact. Thank you so much.